Relational databases store data across multiple tables. For example, we may have one table with information about customers. This data could include a status level indicating the amount of revenue generated by the client. Rather than store all the data associated with an attribute level in the customer table, we store it in a separate table. The two tables in this example share a common value, the status level. We take advantage of that when we need to access data from both tables. When we have a shared column value, we can perform joins on the two tables. This allows us to reference the corresponding data that is stored in the other table. Keeping in mind that SQL statements describe what we want, we can ask, how does the execution plan match rows between joined tables? Typically, we have a foreign key in one table that corresponds to the primary key in another table. In our example, the status level in the customer table is a foreign key to the status table. There are three ways to join tables, with nested loop joins, hash joins, and sort merge joins. Nested loop joins compare each row in a table to all rows in the other table. At each step in the process, it compares keys. Two advantages of nested loop joins are that they can be used to perform any type of join, and they're simple to implement. A disadvantage is that they can have a higher cost than other join methods. Hash joins calculate a hash value for a foreign key and use that to look up the corresponding row in the other table. Hash values for one table are calculated and stored in a hash table, and then the other table is scanned, calculating the hash value for each key value as it goes. Hash joins can be used for joins that have an equality comparison. Sort merge joins start by sorting both tables. It then compares the rows like nested loop joins, but it stops scanning when it's no longer possible to find a match later in a table because of the sort order. Unlike nested loop joins, the driving table is processed only once.